All right, our last example, this is for all you baseball players out there. A pitcher throws the ball to the batter. So we've got our pitcher, threw the ball to the batter, and then the batter hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answers to the nearest tenth of a foot. So let's look at the pathway of the ball. So it starts with the pitcher, and the pitcher throws it straight to the batter. So that's our first distance. I'm going to call that D1. Then the batter hits the ball and it goes straight to the shortstop. I'm going to call that distance D2. So the total distance that we're looking for is just the sum of those, our first distance plus our second distance. So we're going to find the distance of these two segments and then we'll add them together. So because we're going to use the distance formula for these, we're going to want those ordered pairs. So let's count out the pitcher. If we count over and up, we can see it's at over 5, up 5. So that ordered pair is 5, 5. The batter is at the origin, so that's 0, 0. And then the shortstop is at 5, up 10, so 5, 10. All right, so to get our first distance, we're going to find the distance between, I'm going to go ahead and label x1, y1, x2, y2. I'm going to go ahead and throw the distance formula at the top here just so we have as a reference. Our distance formula is equal to the square root of, we subtract our x's and square them, and then we add that to the difference of our y, so y2 minus y1. And we square that and we take the square root of that whole distance. We have some plugging in and simplifying to do. So our first distance, I labeled x1 is 5 minus x2 is 0 squared plus our y1 is 5 minus y2, which is 0 squared. It's the square root of that whole thing. And then we're just going to keep simplifying. 5 minus 0 is 5. 5 minus 0 is 5. So we did our subtraction first. Now we'll go ahead and do the squaring. 5 squared is 25, plus that 5 squared is 25. And then we get the square root of 50. And they said our final answer can be rounded to the nearest tenth. Well, we'll do that in a minute. Okay, so there's our first distance, square root of 50. Now the second distance, we're going to do the same thing, we just have to use the other ordered pair. So our second distance, D2, is equal to, I want to go ahead and label, we're going to use this ordered pair, the x2, y2. So I'll go ahead and label this as x1, y1 up top. And now we're going to find our second distance. So it's the square root of x2 minus x1, so 0 minus 5 squared, plus y2, 0 minus y1, 10 squared. 0 minus 5 is negative 5. Notice how I'm keeping all these parentheses. 0 minus 10 is negative 10. Square root of all that. Now when we square these negative numbers, a negative 5 times a negative 5 is positive 25. And a negative 10 times a negative 10 is positive 100. And we end up with the square root of 125. Okay, so we said our total distance was going to be D1 plus D2. So our first distance was the square root of 50 plus the square root of 125. If you add those together in your calculator and round to the nearest tenth, you're going to get 18.3. So if we're not paying attention, we're going to say it's 18.3 feet. That's kind of what I did at first. And then I noticed that we had this little key right here on our graph. 1 unit is equal to 9 feet. So our coordinate plane is not in feet, it's actually in units. So when we got 8.3 as our answer, that's 8.3 units. But we want to answer our question, how many feet is it? So all we do is we take that conversion. For each unit, there are 9 feet. So we take our 18.3, multiply it by 9, and we get our final answer of 164.7 feet. And there you go.